This is our presentation on how many combinations it takes to make a dollar using quarters, dimes, nickels, and pennies. Hello, this is Hannah. So I was in charge of step 1, which is finding the penny solutions. And I figured out that there would be 20 different amounts of pennies that we would need to figure out the combinations, because we can only use penny amounts that are divisible by 5 in order to use other coins. So then I went from there and I started with 100 pennies because that's the most amount of pennies we can use. And then I went all the way down to 5 pennies, which is the least amount of pennies we can use other than 0. When I went through this, I found that there was not a consistent function that we can use to find all the different penny combinations. As I was working it out, there was some patterns that I saw, but they wouldn't last all of the different combinations. They would only last for some, but not others. An example that I found was when I hit the amount of 35 pennies. From 35 all the way down to 5 pennies, the combination amounts increased by 2, but that was the only section that was true for. After I went through this, I found that there was 194 combinations using pennies. So this paper here just shows the amount of combinations per amount and all of that added together. And then this next slide here shows my tree that I did to find the combinations.
Hi, this is Ellie, and this is step 2, solutions including quarters, dimes, and nickels. So I started this by setting up a visual algorithm, starting with 4 quarters and ending with 1. You can see that on my worksheet. Similarly to Lydia, I noticed that my equations were 1-to-1 functional, and each input, which was a certain amount of dimes and quarters, resulted in a unique output, which was the number of nickels. So the nature of the function was that the number of dimes increased by 1 each time that the number of nickels increased by 2, which makes sense because if you take away 10 cents by removing a dime, you have to keep the value from changing by adding 10 cents back in the form of 2 nickels. Granted, each time the quarter amount changed, the 0 term changed, therefore changing the function. So 1 quarter is represented by the function negative 2x plus 15 equals y. 2 quarters is y equals negative 2x plus 10, and 3 is y equals negative 2x plus 5. The slope remains negative 2 no matter the 0 point. And using the visual algorithm, checking with algebra, and I discovered that there are 18 options using only quarters, nickels, and dimes.
This is Lydia, and Heidi and I were in charge of finding how many solutions of nickels and dimes alone there were to equal a dollar. We started by setting up an algebraic equation where D represents the number of dimes and N represents the number of nickels to equal 100. We started with 10 dimes and worked our way down to 0. We solved the solution algebraically every time to see the output of the function, which would be the number of nickels. We noticed a pattern. Each number of nickels was even, regardless of whether the number of dimes was odd or even. We discovered that there are 11 ways to make change for a dollar using only dimes and nickels.
Combining the solutions found by all 4 girls, we concluded that there are 223 solutions to this problem. A similar pattern can be used to solve the equations that don't involve pennies. The slope of this relationship remains negative 2 as the amount of dimes used decreases, regardless of the number of quarters. Unfortunately, adding pennies to the equation involved a lot of counting, since the relationship was not algebraic and could not be solved using an equation. We did our best to divide and conquer using our own unique methods to solve the different parts of the problem, each taking a coin. The 3 of us on dimes, nickels, and quarters noticed the same patterns, but Hannah, who counted pennies, had no algorithm to follow.